Hi everyone. I'd like to take just a minute and talk about performance evaluation inside of the SOLIDWORKS software. Now when we talk about performance evaluation, we're going to talk about it both for SOLIDWORKS assemblies and SOLIDWORKS parts. And what's really nice about performance evaluation is that it gives us kind of a bird's eye view of our assemblies or our parts rather than just looking at the CAD themselves. So let's take a look at an assembly and see what kind of information the performance evaluation actually gives us. Where we activate performance evaluation is from the Evaluate tab of the Command Manager. You can see it's roughly halfway across toward the bottom. And launching performance evaluation, in this case in the scope of assemblies, you'll note that we get quite a bit of information here. Let's take just a second and digest this. So when I say we get kind of a bird's eye view of our assembly, this is the type of stuff that I'm talking about. So we get information about, what all files were opened with this assembly and their open times. So in this case, we can see that this took 0.47 seconds for our support frame, whereas everything else took considerably less. So what can we glean from that, right? Maybe there's a lot of graphics triangles that are involved here, right? They're causing it to open up slower. So again, good information that we can gain from that. It also tells us if we have any previous versions of the files inside of this assembly. At this point, everything I have is on 2025, so I'm good. Also, if things have been modified when they've opened, maybe they weren't up to date, right? Whenever that assembly was last opened, we get that instance, right? And you can see there's two of those documents here. If I want, I can choose to show these files, and you can see there's two files that kind of weren't up to date, right, whenever we last opened this. So again, knowing that information is pretty valuable. And then as we move on down, something critically important that often gets overlooked is the number of graphics triangles in a model, because truth be told, that is what's really taxing the SOLIDWORKS software whenever we go to zoom, rotate, pan, whatever the case may be of our model. It's having to redraw all of those graphics triangles every time. And in this case, you'll see that it actually reports our total number of graphics triangles for the assembly, but if we scroll over, we can also see the individual graphics triangles for each component. And in this case, you can see we actually have nearly 60,000 graphics triangles on, looks like a hex flange nut, right? So this is also an example of why in the CAD world, you generally don't want to model threads unless you have to. They do add a lot of extra facets and faces that then correlate to an increased number of graphics triangles. So again, good information that we can glean from this. Maybe we want to look at a nut with cosmetic threads, right, to cut down on those graphics triangles. If we look at rebuild performance, we get, again, some very valuable information here. We can see if there's any circular references built into the assembly itself, right? Maybe a component is mated here, but also mated there, and it gets in kind of a solve loop, right? So we can check for that. And again, we don't have any in this case, which is great. We also get information about the total number of mates in our assembly. And valuable statistics as far as total number of components, the various part configurations that are being used, the number of subassemblies that we have, if they are unique part files and how many of those. Again, a very valuable understanding of what's the overall scope of what my assembly looks like. So it's an excellent tool. Again, this is available on the assembly side, but it's also available on the parts side as well. Again, since we are dealing with parts, the information gets a little more limited because they're not quite as complex. We'll look at opening up it's the rock grate that we want to open up here. And we'll just take a look at it. You can see as it opens up, right, we've got our grate that goes in the bottom of the grill. And if we want to go and look at the performance of this part, again, on the Evaluate tab, you'll see that I have access to performance evaluation. And when I do that, the dialog box is a little bit smaller, but again, we get some of that valuable information here. Things like our feature order, right? So it tells us, in this case, it's capitalizing it by time. We can see that our linear pattern 4 looks like it takes up nearly 70% of our rebuild time. So we know that it's a very taxing feature in the part, right? We can also glean our total rebuild time, in this case 0.16 seconds, how many graphics triangles are included in this part. Again, valuable information that if we need to look at maybe defeaturing the part, right, or creating a configuration that was simpler, we can start looking toward that so that we're not taxing the assembly later on. So if you're ever curious, right, that 30,000 foot view, what do my parts look like? What do my assemblies look like? I highly encourage you to click on the Evaluate tab, check out Performance Evaluation, and then make a little more educated decisions about how you want to proceed from there. Thanks very much. Have a great day.